Hello everyone, this is Kenny from Tech and welcome back to the channel. I'm going to put out a series of videos where we are going to look at data science related topics. So we are going to work on some data analysis using Python and things of that sort. And I believe the first video I should probably make is maybe look at the rudiments, some of the things we'll be looking at, and Python just comes to mind, and definitely some of the libraries that we are going to use. So in this video we are going to look at NumPy, and in subsequent videos we are going to look at pandas, matplotlib, seaborn, and other things. And in later videos we are going to build out some machine learning models and look at some analysis of it, right? So in this particular video we are going to look at NumPy. This is a two-part series. This is a part one. The part two will follow shortly. And like I always do, I have this in my GitHub repo. So now when you open up this repo, you have a number of files over here, but the two main important files are the notebooks over here. So I have the NumPy and I have the templates. So when you open up the templates, it has everything we are going to work out over here. And like I said, this is a template, so it includes all the notes and everything I have commented out over here, even before starting to write everything as you see me do later on. So this is the template, and this notebook, the NumPy, is actually everything I have typed or recorded this video with, and that's essentially what we have over here. Now I purposely did this because I want you to have a feel and exactly the template that I'm using so that you can follow along. So I'll suggest you open up the template and you code along as you watch this video. So in this video we are going to work in the Anaconda environment, and this is Jupyter. Now if you don't have this installed, I have a video or a link in the description below on how to set up with this environment. Now alternatively, you can use Google Colab. So if I'm to come in here and type in Google Colab and click on this first link over here, with this particular one you can just click on new notebook, and you wouldn't need to install the Anaconda. You can just use this straight away. The interface is the same, and everything over here will be provided in here for you. But I'm going to use the Jupyter notebook. So now let's get started. So what then is NumPy? NumPy stands for numerical Python. It is a Python library used for array data computations and manipulations. So if you're a data scientist, like I said, you are going to use NumPy most of the time. It's by far one of the popular Python libraries when you are working with data. So NumPy is faster than the traditional Python list. So it is one of the popular data science libraries. It makes working with numerical data easier and faster. Now NumPy is interoperable because it supports a wide variety of computer hardware and software. Now originally NumPy was written in C, and it makes it very interoperable. Now it is an open source library, and for that reason it has a very large community for which you can seek for support or assistance whenever you are working with it. And it is definitely very easy to learn, and that's why we are going to learn NumPy today. So one of the keywords that comes to mind whenever you are dealing with NumPy is what we call an array. So an array is a data structure which consists of a collection of data types. So you can have an array, like I said, an array will look like a list. So you can have an array of numbers, an array of names, and things of that sort. Now, with specific to array, we can have a 1D array, which in this case means a one-dimensional array. We can also have a 2D array, which is a two-dimensional array, and we can have a 3D array, which is a three-dimensional array. Now when we talk of a one-dimensional array, this, as you can see over here, is only moving in one direction. So there's a dimension which is obviously in the x-axis, so this is the one direction or the one dimension. This particular one, in most cases we are going to refer to this as a matrix, will have two dimensions. So this is the x dimension or the x direction, and this is going to be the y direction. Now this is going to be a 3D array. So these are the directions. This is going to be the x direction. We are going to have the y direction over here, and there's also another direction that moves in the z axis. So mathematically we call this a vector because it has only one dimension. Then this becomes a matrix, and this becomes a tensor. A tensor is basically a matrix of higher dimension. So now that we have a basic understanding of the theoretical concepts with NumPy and arrays, let's look at how we can use them. So first of all, we need to install NumPy. Now I already have NumPy installed on my system, but let me quickly show you. So let me just come into my Anaconda command prompt. So I'll click on this, and I have this command prompt window open up for me. Now, like I've stated over here, it is a Python package, so you can just do a pip install NumPy. So if I type pip install NumPy, like I have over here, and press enter, this is going to take some few seconds, but clearly it says requirement already satisfied. I already have NumPy installed on my system, so it is already satisfied. So if this is the first time you are going to use it, it is definitely going to run through the installation. So let me close this up and let's continue. So we already have this installed. Now let's see how we can import NumPy, because after installation we need to import it and now use it. So in importing NumPy, we just have to type import NumPy, and that's it. So this is going to work. Now within this environment, this is very interactive because whenever we run a code, we can simply get feedback in the same interface. So over here, I can do a shift enter to run this whilst I have this cell activated. You can see this green marker over here showing that this cell is activated. If I come here, it changes to this particular cell. Now I'll go back here, I'll click here. Now I can run the cell by clicking on this button over here, which is run. But there's a keyboard shortcut. I can simply do a shift enter, and that's basically what I'm going to use. So you can see that there's a label over here which shows 1. So this is the first cell I've run over here. Forget about what you see over here for now, but this is the first cell I've run over here. So I now have Python or NumPy over here. So now I would want to check the version of NumPy I have installed. So I can do a print NumPy. Let me just do NumPy. I'll do a print NumPy dot underscore underscore version underscore underscore, and if I should run it, which is going to be a shift enter, you can see that this is the version of NumPy that I have installed on my system. Yours could be different depending on when you are watching and when you are installing. So I'm using the version 1.19.2, but definitely if you have a higher version or a lower version, I think most of the things you are going to do, you should be able to do same. All right, so now this is we importing NumPy, but typing NumPy a couple of times can be some kind of a daunting task. So what we can do is we can give it an alias over here. So I can do import NumPy as np, and now instead of typing NumPy all the time, I can just type np over here. So I need to run this once again, so I'll do a shift enter, and now if I do a shift enter, we don't seem to have any problem over here. But then let's do np, and we also don't have any problem over here. So instead of NumPy, we are going to type np. All right, so in this particular cell, we are going to create a NumPy array. So in order to do so, we have to declare a variable. So let's say we have x. Now x is equal to np, which is the NumPy package dot array. So now I want to create an array. So over here, I'll open a bracket and I'll do 1, 2, 3. So just by doing it this way, it looks like a list. Like I said, it is definitely going to look like a list. Now what I can do is I can now print out my x, which is going to be a collection of these data types 1, 2, 3. So if I do a shift enter, I have this array printed out for me. Now we could have also used the print statement, which in this case is going to be print x, and when I run this, you're also going to have the same thing. But clearly typing out print and just doing print this way. We are going to use this a lot because it makes our work very easy. So now let's check the data type for this X NumPy we have over here. So I can bring out the type method over here and do a type X. So I want to check the data type for this array. Now when I print this out, we can see that we have a NumPy.ND array. So this is a NumPy, which is an n-dimensional array, and later on we are going to see the various dimensions as I have illustrated over here. So now let's come down and see how we can create a one-dimensional array. Now this example is a perfect example of a one-dimensional array. So let me just copy this, Ctrl+C, and bring it out over here. And if I'm to print it once again, we have this. Now you can see that we have the dimension over here. So let me just bring this cell up. So after highlighting on the cell by clicking, I can use the arrow buttons over here to bring it up. So as you can see, check dimension is now up. All right, and that's exactly what I want to do with this 1D array that I've created over here. So now I can do X, which is the array dot n dim, which is a dimension. And now when I do a shift enter, I can see that this is of a dimension 1. So this is a one-dimensional array. Now let's create a 2D array. So I'm going to say y, and y is going to be equal to np.array. And over here, let me just press enter so that we open things up very well. So over here, I'm going to have this bigger bracket, which is kind of going to encapsulate everything I have over here. Remember, over here I have only just one square bracket, but over here I'm having a bigger square bracket. Then inside of this I'll have, let's say 1 2 3, then I'll have a comma, and I'll have another bracket, and I'll say 4 5 6, and let me just print y over here. So when I run this, you can see that I have this showing up over here. Now let me just click on this particular cell and come in here. So I can click on this button, which is insert cell below. So when I click on this, I have this cell beneath here. Moving forward, that's what we are going to use very often. So what I can now do is I want to check for the dimension of this array that I've created over here. So I can do y.ndim, and when I run this, now you can see that I have a 2 printed out over here. So this basically means that this is a 2-dimensional array, and this is definitely going to look like what you see over here because we have like 2 rows and some columns showing up. Now let's look at a 3-dimensional array. So for 3-dimensional array, I'm going to have a variable z, and I'm going to say np, which is numpy.array, and over here let me just open this up and let me have a square bracket this way, and I'm going to have another square bracket like this, and inside of this I'm going to have a square bracket again. So over here what I can do is I can have 1 2 3, and I'll do a comma, and I'll do 1 2 3 again. It doesn't really matter. So now I can run this. Let me just come down here and print this out over here. So z, now I have this showing up over here. Let me add a cell below here, and let me just do a z.ndim. Now when I run this, we see 3 over here. Now you may be surprised. Yes, the elements we have over here, we have 2 elements over here in terms of the arrays. Okay, and why is this giving us a 3 and this is giving us a 2? Now this may sound very confusing, but take it from me. Now the number of brackets you have in here will kind of depict the dimension that we are heading towards. So this is definitely a 3-dimensional array because we have 1 2 3 brackets before we get into the main thing, and over here we only have 2 brackets showing up over here, and here it is just 1 bracket. So the kind of brackets you have will show the dimension in which you are getting into. But let me also add in another element over here, and let me just do a 6 7 8. So let me run this once again, and when I run this, it is still going to be a 3-dimensional array. Now let's also look at a method over here, and this is where we want to check the shape over here. So this returns a tuple with each index having the number of corresponding elements. So remember, we already have x and y declared over here. Remember, x is a 1-dimensional array. So let me just come down here and put out this. So I can do x.shape. When I do x.shape this way and run this, you can see that I have 3. Now 3 meaning this array has 3 elements on the row. 3 elements on the row. So it is 3 comma and nothing shows up. Now let's look at this particular one for the y. Remember, y has 2 rows and it has some columns showing up over here. So let me just also put out a cell beneath, and I'll do y.shape. So when I run this cell, you can see that we have 2 rows and 3 columns. Now similarly, if I'm to come in here and put down a cell and do z.shape and run this, we are seeing that we have 1, 3, and 3. So this is going to be the x-axis, this is going to be the y-axis, and this is going to be the z-axis. So now let's move on and let's look at concatenation. Now in Python, we can have something like first name is equal to, and let me put out my first name over here, which is Kenneth, and last name is going to be equal to my last name, which is Bruni, and I can say full name is going to be equal to first name plus, and I can have last name over here too. And if I want to print out full name and run this, I see Kenneth Bruni over here. Now you can see this has been concatenated. This is what we know. We can do same with arrays, and I can equally, in order to format things up very well, I can just add an empty string over here, and when I run this, we see Kenneth Bruni nicely printed. Now we can do same with arrays. So let me just comment these ones out and let me run it so that you have an empty cell over here. So for the concatenation of arrays, let's say we have an array x, which is equal to np.array. And by the way, by doing this new x will overwrite anything we had x before it. So let's have this array, and let's have 1, 2, 3. And let's also have y, and y is going to be np.array. And this is also going to be 4, 5, 6. So in order to concatenate or join these two arrays, all that we can do is we can do np.concatenate, and over here you open up this bracket and open up another one and do x, y. So now when I print this out, you can see that we have 1, 2, 3 for this x array joining up with 4, 5, 6. Okay, now if I change the order from x to y, or from y to x, and print it out, you can see that the order also changes. Now I can also concatenate the same array, so y is concatenating it with y, and when I run this, as you can see, you have 4, 5, 6 and another 4, 5, 6. All right, but what I want is x and y. So this is concatenating. Now as you can see, we are concatenating along rows, okay, but in some cases we may have a complex matrix or something which is a little bit complex. So let me show you with an example. Let's do np.array, and let me just label this x. So x is equal to np.array, and let's have a 2 by 2 matrix over here. So I have 1, 2, and after this I will also want to have 3, 4. All right, so let me just print this out so that we see it very well. So this is what we have for x. Now let's do some for y. So y is going to be np.array, and over here I have 6 or 5, 6, and what I have over here is 7, 8. And if I'm to also print y over here, you can see that we have this. All right, now I want to concatenate along rows. So I want this row to join up with the other row. I think I should have, let me just put up another cell over here so that you see things very properly. So let me just copy this, or let me just cut this and put it over here. And let me just print this out. And let me also print x over here. Okay, so I want to concatenate these along rows. So what I can do is I can do np.concatenate, and I want to concatenate x and y, but over here I'll also need to specify an axis. So I'll do an axis is equal to 0. Now when I run this, yes, we have a problem over here. We needed to bring a comma. So when I run this, you can see that this has been concatenated along columns. So let me change this back to 1. And that's exactly what we have over here. So as you can see, we have 1, 2 for the first row over here, joining up with 5 and 6. And the second row will now have 3, 4, joining up with 7 and 8. And that's exactly what we have over here for this new matrix. And we can equally do it along the columns as well, and that's exactly what I did previously. So let me put out a cell over here, and let me just copy this. I'll do a Ctrl+C, and if I print this out and change the axis to 0 and run this, we can see that the concatenation is being done along the column. So as you can see, this first array is just being joined up by this, so this is just continuing, and that's exactly what you have over here. Now we can use the stack functions as well. So for the stack functions, I can do np.stack, and let's use the same x and y over here. So I'll do x and y. Now when I run this, we have an issue over here, and that's because we are using a function, so we need to add these parentheses over here. So when I run this, you can see that this has also been joined, okay, with a stack, and it is almost behaving like this, but in a different way, one way or the other. What a stack basically does is it picks up the entire array and stack it upon an entire array. This was concatenating, so this was joining. So if you are very observant, you could see that this, okay, let me just label this as, let's say, k. So k is equal to this, and let me just print out k over here. Now I would want us to check the dimension of k. So I can do k.ndim, and also check the shape as well. So there's an order of 2 because this is just a 2-dimensional array. So clearly you can see that the brackets over here is just 2. All right. Now if I'm to do the shape of k and run this, you can see that this is a 4-row by 2-column matrix, and that's exactly what you have over here. Now let me save this as w, so the one I'm stacking over here. So w, and let me print out w over here. So we are definitely going to get the same thing. Now let me add in a new cell beneath this, and I'll do w.ndim. And when I run this, you can see that the dimension is 3, because as you can see, we have 1, 2, 3 brackets before it starts. So that's kind of giving us a clue. Now let's look at the shape as well. And the shape, so this is going to be a 2 by 2 by 2 tensor. Okay, there's a higher order matrix, and that's exactly what you have over here. Now we can do an H stack. So let's continue with np.hstack and hstack. So hstack, once again, there's a function, so we can do x comma y. So this is going to stack it along the rows. So when I run this, you can see that the stacking is now done along the rows. It is almost behaving like what we have over here. So this is going to be along the rows. Now you can do a v stack, and a v stack is going to be across the columns. So let me just copy this and change this to a V stack. So when I run this, you can see that this is also stacking over here. Now clearly you can see that this is definitely the same as the concatenation. This is behaving like the concatenation we had over here. No, in the case of the concatenation, this is going to be a two-dimensional matrix, but then this is going to be, yeah, this is also going to be a two-dimensional matrix. So they are basically the same. Now we can do a D stack, and a D stack is going to stack it in depth. So let me just paste it once again and change the H to D. And when I run this, this is going to stack it, and this is now behaving like what we did with the default stacking. So there are a couple of ways you can do the same thing, and some of these things will come in handy whenever, let's say, you have two sets of data sets or two things that you need to join and work your way around it. Now let us create some kind of a zero matrix, and a zero matrix, let's say we have z, a new variable z. So let's say np.zeros. Now when I just do np.zeros, I just need to specify the shape of the matrix that I want. So for the shape of the matrix, I'll just put out another bracket over here, and I'll say I need a 2 by 4 kind of zero matrix. So when I come down here and run this, I now have a 2 row, and so this is the first row and this is the second row, and I have 4 columns showing up over here. If I'm to make this a 4 by 4, this is exactly what I have over here. You can also create one for ones. So for the ones, let me call this X, and I can do np.ones, and I just need to specify the shape. So for the shape of this one, I want a 5 by 5 kind of shape, and I would want to print this out over here. So when I run this, you can see that I have a 5 row, 1, 2, 3, 4, 5, and I also have 5 columns showing up over here. All right, so basically this is we starting with the basics, and as we move along, we are going to look at some intrinsic details of everything we are trying to do over here. So the next example I would want to show is when we want to index. So we want to return a value based on the index. So let me just put this out over here. Now let's have X once again, and this is going to be np.array, and let's just have 1, 2, 3. Now if I'm to print out X and run this, we have this showing up over here. Now let me put out a cell beneath this, so I'll create a new cell, and if I'm to do X, and remember the way we used to work with strings, we can pick up an index. So the way Python indexing works is the first element over here will have an index of 0, the second element, which is 2, will have an index of 1, the third element, which is 3 over here, will have an index of 2, and it goes on and on. So if I just want to print out 1, the index of 1 in this case is going to be 0, so I just put out X and a square bracket 0. Now when I run this, I'm going to see 1 printed out over here. Now if I'm to do same and do 1, the index of 2 is going to be, the index of 1, which is 2, is going to be printed. Now if I do 2, you can see that 3 is printed. Now let's say if I do 10 and run this, clearly you see that index 10 is out of bound for axis 0 with size 3. So definitely we are out of range over here. Now what if I just want to print out the last one? I don't want to count the index. I can simply do an index of -1. So an index of -1 is definitely going to print out the last element over here. If I'm to add in more elements, and let me just come over here and do a comma and let's say 7 and run this, it is definitely going to pick up 7 over here because 7 is now the last index. Now with regards to index, let me also show you this. So I'll create a new cell over here, and let's do np.array, and over here I'm going to use a 2 by 2 matrix. For the first time, let me just do 1, 2, 3. No, let me just do 1, 2 and a comma, and I would want to have 8 5 over here, and let me just give it a variable. So y is equal to this, and now let me print out y. All right, now let me also bring out a cell over here, and let's do a y dot shape because we want to see, yes, this is a 2 by 2 matrix. All right, now if I would want to print out the entire row over here, that's the first row. So over here, the indexing also works out over here too. So this is the first row, and this is the second row, and it's the same way. This is the first column, and this is the second column. So if I want to print out the entire row, which is the first row, I can simply do 0 because the indexing starts from 0. And now when I run this, you can see that I have 1 and 2 printed out over here. If I want to print out the last row, or the second row in this case, I can just do an index of 1 and run this, and as you can see, I have 8 and 5 printed out over here. Now alternatively, I can do an index of -1, which is definitely going to print out the last index for me. Good. Now what I want to do is, what if I just want to print out 1 out of this matrix y over here? Now in order to do so, then I need to do some indexing. So with the indexing, all that I need to do is, the question I need to ask myself is, where can I find y? Where can I find 1 in terms of rows and columns? So in terms of rows, it is going to be in the first row with an index of 0. So I can simply do 0 for the index, and I'll pass in a comma. And in terms of columns, where do I find 1? The column is also going to be the first column, which is also going to have an index of 0. So when I do y with a bracket of 0 0 and run this, we are going to return only 1. Now what if you want to print out, let's say 8? So the first question, which row does 8 fall? The row over here is going to be the second row, and in terms of index is going to be 1. So I just have to replace this with 1. And the obvious question I also need to ask is, which column does this fall? And it is falling in the first column, so the index is 0. And if I just maintain this over here and run this, we are going to see we have 8 printed out over here. So this is one way of returning some specific values over here. Now we are going to look at slicing. So let's work with this over here. Now let's have a matrix. Let me call this x, and let's do np.array. And over here, I would want to have a 3 by 3 matrix. So I'll do a 1 2 3 over here. And I'll do a comma. Now I have 4 5 6. I'll do another comma, and I'll have 7 8 9. And let me just print out x over here. Let me just have a cell beneath this, and let's check out the shape of x. So x or shape, and yes, we have a 3 by 3 matrix over here. All right, so this is going to be a very perfect example for which we can do this slicing. All right, so I must confess, slicing arrays can be a little bit confusing, but we are going to take it one step at a time, and I'll show you some tricks which will not confuse you moving forward. So first of all, let's print out the whole thing. And if I'm to run this, everything is going to be printed out. Now if I'm to bring out the square bracket over here, it is expecting a start and an end, and we can have a colon in between. Now let's defer the step to another example. So we are just looking at this particular one. So let's put out a column over here. Now if we leave this column blank, as you see over here, then it is just going to print out everything. So the beginning of the column will be the start and the end. All right, so when I do this and run this, it is going to print out everything. Now I can equally do a comma and bring out a column over here. So in this case, this now becomes the row part, and this now becomes the column part. The moment we have comma over there, then we are segregating rows and columns. So once again, if I run this, okay, we are still going to have this. Now if you start off by writing out this, it makes your work very easy for you. So now you ask yourself, let's assume we want to print out this 147 and not everything over here. Now, in terms of rows, and we'll be dealing over here, in terms of rows, what do you want to print out? We definitely want to print out row 1, row 2, and row 3 because 147 is found in row 1, 2, and 3. So in terms of rows, we are going to leave it. Now let's come in terms of columns. What is going to be the starting of our columns? This is the first column, so index is 0. So we can leave it blank or we can add in 0 over here. It doesn't matter. We want to start from 0. And where do you want to end? You want to end at 1. So we don't want to print out 2 or any other thing that comes after it. So the ending index is going to be 1. And now when I run this, you can see that we only have 1, 4, and 7 being printed out over here. Now in that same way, if you want to print out this column we have over here, the middle one, which is 2, 5, and 8. So for 2, 5, and 8, we need to ask ourselves, when it comes to the rows, yes, we want to print out everything because 2 we want to print out, 5 we want to print out, and 8 we want to print out. But the columns is now going to determine which will be cut off and which will be printed. So now in terms of the starting point, we need to start at 1 because this is the first index or index of 1. This is 0. So if we had to do an index of 1, and where do you want to end? We want to end at index 2 because we don't want to print this out. So if I do 2 and run this, you can see that we have 2, 5, and 8. Now let's assume we also want to print out just the last one. If your guess is as good as mine, we don't have to touch the rows because as far as rows are concerned, we are printing everything, but we are limiting the columns. So with the columns, we want to start with index of 2. So when I do 2, I can leave this blank because any other thing can be printed. So when I run this, it gives me this. But in order to also enforce some kind of restraints, we can put out 3 over here, which is definitely going to give us the same thing. All right, so that's with slicing. Now let's look at this particular example. Now you can create an array from a list. So let's say we have a list, and let me just have this as numbers. So I'm going to have this. I'm going to have a variable numbers, and this is a list. So 1, 2, 3, 4. And let me just print out numbers over here. And when I run this, we have this. Let me put out a cell beneath this, and let's check out the type of numbers, the data type of numbers. Now when I run this, you can see that we have a list over here. Let me also add in a cell. And what I can do is, in order to make this numbers list an array, we can simply do np.array, and we pass in numbers over here. Let me save this as x. And now when I print out x, you can see that we have this showing up over here. Now if I am to check for the data type of x, you can see that we have a NumPy over here. Now this can come in very handy because sometimes the raw data will be presented to you in a form of a list. Now you need to probably maybe convert it into an array so that you can have access to all these functions and methods within arrays. So last but not the least, let's check the data type of an element, and this is very important. I would want to do this in reference to an example we demonstrated over here. So now let's just copy this when we were printing out ones and zeros and things of that sort. So let me just print this out over here, and now we have ones showing up over here. Now let's bring out a cell beneath this, and let me just reduce this to a 2 by 2 so that we don't write a whole lot over here. So let me do an x, and this time around I just want to print out this first element over here. So I can do a 1,1, sorry, a 0,0, because that's going to be the first index. And when I run this, we are going to see a 1. Now I can wrap this up, and let me just cut this to check out the type. So I'll paste this over here, and in checking out the type, you can see that this is of a type float 64. Good. Now this is the data type. You can equally check out the same for the rest of the elements over here. Now as far as this goes, we can change the data type to what we want, and in some cases you may want to change from float to maybe an int. So all that we need to do is, by default, it gives us a float. We can just pass in a parameter over here. So we can do a D type. So D type stands for data type, and inside of this we can say int. So now look over here. Everything you see over here is 1 point something, or probably 1.0. Now when I run this, you can see that now we have just one showing up over here. And now when I check out the data type, you can see that we have an int 32. This can come in very handy when we are working with some kind of data types and you need to enforce or change from one data type to another. So this is going to be the end of the first part. The second part, we are going to look at some mathematical operations that we can perform with NumPy, and it is going to be as interesting as the first one. Now, if you find this tutorial very interesting, there are a couple of ways you can help me grow my channel. Kindly subscribe to Tech, and don't forget to hit on the notification button so that anytime I release a video, you'll be duly notified. Also, share this video with friends and family who find this content very useful. At Tech, we say learn programming. You can do it. Bye bye, and catch you in the next video.